It is 1 o'clock here Pacific time. How's everybody doing today? Hopefully good. So this is a Science Live session. My name is Amy Defoe. I'm one of the science teachers here at Graduation Alliance. Maybe I'm one of your teachers. Maybe you have one of the other ones. It's all good. We're going to be going over the same curriculum. And today we're going to be talking about weather patterns. And I'm going to show you guys how to upload and download a document. But before we get started, let me get a little bit more comfortable here. Some housekeeping items. We'll start off with the audio. So when you come on, you have the option to turn your microphone off. So you just click the little microphone thing and you'll get a line that goes through. So that mutes you. So that mutes if you are talking or if there's background noise, then that mutes that noise, which is good. If you're in an area where you've got some background noise going, then we don't have to hear it and we don't get distracted. But you can also unmute yourself so that you can join in on the conversation. You'll also be able to ask questions, get some help on some assignments throughout this lesson as well. Okay, so again, you can mute yourself, you can unmute. I do love feedback. I do love interacting in these lessons. In these sessions, it's great because, we might be working remotely, but of course, hey, here we are face to face. I'm your teacher, you're one of my students, or you're a student here at Graduation Alliance, all the same thing. It's great to have that interaction, that face to face. So you can also turn your video off or on if you choose to say hi, show your face. It's up to you. I enjoy seeing my students, so it's kind of nice to see that. But totally, of course, your decision, your call. Recording. All of these sessions are recorded. So right now this is being recorded. We do this for a couple different reasons. Of course, if you miss a session, you'll have the opportunity to go back to the session when a time is good for you. It's really awesome because every week I like to check. We have like a little library of all of these different sessions that all the teachers in different curriculum areas are doing. And oh my gosh, our library of these lessons is growing and growing. So, maybe you're not on this particular topic yet in the course, and maybe, in a couple weeks you'll come to it and you'll be able to go back and view that. Or, maybe you take a different course and you'll get to be able to see those sessions as well. So that's another good thing. Also, if something comes up during this lesson, you're like, oh, what was Amy, what was she talking about? You can go back and see that session. So again, great that these are being recorded. So I appreciate you guys joining today. We'll go ahead and get started. Let's see, I did recording. I talked about audio, video. Oh, chat. You can also send a message through chat. So you can just type in if you have a question or a comment. You can answer questions through that. That's great. You can still give feedback and interact. So you can do that. I'll be checking my chat. It pops up and lets me know a chat came in so I can take a look at that. Awesome, guys. Okay, here we go, science. Okay, so what we're going to look at today, I did a bunch I was doing some biology the last couple of weeks, so I was like, let's switch it back up to earth science. So we're going to look at earth science semester 2. We're going to be looking at weather patterns. We're going to be looking at the Coriolis effect as well. And so that's one of the assignments. It's 521. We'll have a section in there where you'll have the option to ask questions. It's like a little Q&A if you're having problems with an assignment or a particular topic, and it doesn't have to be about earth science. It could be about something else. This would be an opportunity for you to get that, quick response here, live session response from me or help that you might need, okay? And then we'll go to our little skill section, and what we're going to talk about today is downloading and uploading a document. There is an activity 5.2.1, it's called the Coriolis effect, and it involves having to download a document, do some editing on it, like, pick a letter, which arrow, and then you have to upload it back. Okay, and I wanted to make sure that that was, as easy as possible for students to do. And then, of course, we'll end, of course, with questions and answers again, so you'll have another opportunity before we end this session to get anything answered. Okay, agenda sound good? Looks good? Yes. Okay, and think about, I always say this throughout the lesson and also at the end of the lesson, if there's a topic that you would really love me to cover next week, please send me a chat, send me an email. You can tell me right here. And I would love to do a student, requested lesson on a particular topic. I would love to have that feedback from you if there's something you would like to see a little bit more on. That would be helpful for me. So think about that as we're going through this session. Okay, so what we're going to talk about today is weather. So in Earth science, it starts talking about the different spheres on Earth. How we have, the hydrosphere, which is like the water cycle. We have the biosphere, which is the land. We have the atmosphere, which is what we're going to deal with here with weather, okay? So talking about these different spheres that we have on Earth. And I don't know how your guys' weather is at your house. I have my blinds shut so you can't see because it's pretty bright outside. I live in Eastern Washington. So I live, people are like, oh, Seattle must be cold and rainy. And, we've got these mountains that separate the state of Washington. And over on my side, we are nice and sunny and we get lots of seasons. We get lots of highs and lows. So right now it's 100 degrees here, which for people from Washington will be like, oh my gosh, but in Eastern Washington, that's pretty normal. But what we're dealing with right now is forest fires because it's so hot and dry right now that we're getting a lot of fires. And so everybody is kind of stuck inside today because it is smoky out there. So if I was to show you, you'd see this nice old haze. It's not a nice haze, but that's what's going on here in my weather, which is a bummer because it's summer and we want to be outside and enjoying it, but we got to be safe and we can't go outside. So that's what's going on here. Anybody got any fun weather in your area? Hopefully you're not dealing with the same thing. I know it is fire season, and so maybe you're getting some of that as well.
Yeah, it's sunny
okay.
Here.
Okay, so what is weather? When you think about that, weather, what comes to mind when you think of the word weather? How do you try and explain that to somebody? Weather. Growing up, my father always had to watch the weather before dinner. It was like, oh gosh, so it was always having to know, what we could expect outside. People were like, well, weather, it's just what it's going to be like outside, right? It's kind of hard to define. When we define weather, we talk about it as the condition of the atmosphere at a particular time and place. So again, we're dealing with the sphere, the atmosphere. So up above, we can say that. And what we're doing is we're talking about the condition at a particular time and place. So we're talking about today is Thursday. Here in Washington, it's Thursday afternoon. I'm in Wenatchee. So when we're talking about my weather, we're talking about, what is it like outside in this atmosphere at 1 p.m. on Thursday in Wenatchee, Washington. And we could tell you that it is sunny and hazy. So when we think of weather, we think about this kind of stuff. Is it sunny? Is it partly cloudy? You have rain, snow, sleet. That's what we're talking about when we're talking about weather. And we're not talking about it over a period of time. It's very specific. It's probably, that particular day and in a particular place. Because, of course, my weather could be completely different than, your weather. So that's what we're talking about weather, is it's a particular time and place. And lots of times that gets confused with climate. So there's a question in that unit. It talks about weather and climate. What's the difference? How do you distinguish between the two? They are somewhat similar. It's just that climate is what we talk about. It's like an established pattern of weather over a period of time, a long period of time. So it's like taking the daily weather and then tracking it for, a year, so that you're collecting what is kind of like the normal or the average weather. And that's going to be your climate. Okay, so usually when you think of climate, you'll see some type of map like this that's kind of showing you, this is based off of temperatures. Okay, so, the weather in the Arctic, of course, is going to be colder. And then, of course, you get here different colors in the equator, and it's going to be warmer. So we're not talking about, with climate, we're not talking about a particular day. It's over time. Okay, so the difference between climate and weather is what is happening, the condition of the atmosphere on a particular day, particular time, and in a specific place. climate is going to be the pattern that usually that area has over a long period of time. Okay, so that's the difference between those two. Okay, well, what influences the weather? What determines if we have clouds one day and sunny and the temperatures? Anybody have any ideas?
What influenced the weather? Like clues, like as say if it's.
Well, it's kind of weird to think about. One, the influences is we have to think about the shape of the earth. So the earth is a sphere, okay? So we think like a round ball. And we have this line here called the equator, so kind of the center of that circle. And what happens with earth is it sits on this axis. So it has a little bit of a tilt, as you can see here. It's about a 23.5 degree tilt, so just slightly tilted, and we're always tilted, okay? So because of that, that tilt, you can see the sun's rays. They hit in specific locations, and as we think about the equator, that's where you get the most of the sun's direct rays, which is the energy which is going to cause us to, heat up. So when we think about what influences the weather, we want to talk about this. The earth is sitting on this tilt. And as the earth revolves around the sun, certain areas are getting more of the sun's direct rays. With the equator, it's usually year round, but they're always directed towards the sun's rays. So they're getting more of that. So that's why, places around the equator usually have pretty consistent warm temperatures. So because of this tilt, sometimes we're going to be tilted towards the sun, and sometimes we're going to be tilted away from the sun. And this is what causes these seasons that we have. Right now we're in summer, we're going to hit fall, winter, spring, and it keeps going. And that's because of the tilt. I'll show you a picture. Let me check this message though here real quick. Your sound is, it's looking, is it Marcia? Is that how I say your name? Your sound is on. I'm not hearing you though. Can you hear me? It doesn't look like you're muted at all. You might have to turn your sound up on your computer. Let's see.
So can you hear me now?
Did you hear me? I hope everybody can hear me. Okay, so let's take a look at this. So we talk about these seasons, okay, and that's because of the tilt of the earth on the axis, okay? The biggest influence, one of the biggest influences of the different weather that we get. Okay, so what hemisphere do you guys live in? Are you guys in the northern hemisphere or the southern hemisphere? So as we think about it, we have this equator. Are you up here or are you down here? Think of North America. North America is in the northern hemisphere. So we're up here in this section. Okay, so here we have the sun. Oh, great. Thank you. Awesome here. Okay, so here we have the sun. Now, of course, the earth revolves, meaning it goes around the sun. The sun stays in the same spot. So all the planets are revolving around the sun. And you'll see, we think about when we're over, let's start with here. Let's start over here in June, well, summertime, okay? So here we have what we call the solstice. And the solstice is what we think of either the shortest or the longest day of the year. And that has to do with this tilt. So here in June, the beginning of summertime in the northern hemisphere, which would then be opposite in the southern hemisphere, because you can see southern hemispheres over here, they're not getting much of that sun. So if you look at the way that the rays are hitting the surface of the earth, the northern hemisphere is getting most of that sun's energies. So this is why we have such longer days in the summertime, okay? Because we are tilted towards that sun. Okay, and then as we move to, fall time, equinox, we call that equinox because, of course, as you can break this word down, equal. So we have equal day and equal night. So both places are getting about the equal amount of daylight and sunlight. Okay, so that's why, you can think about September and springtime. It's pretty equal amounts of day and light. And then, of course, as we move, we hit the December solstice here in the winter, we can think about here, if you look at the sun's rays are, because of that tilt, the northern hemisphere is tilted away from the sun, so our days are shorter. We're getting less of the sun's rays. If you're in the southern hemisphere, hard to believe, it's summer in December because the sun's rays are directed right there. Okay, so because of this tilt that we have, it determines the amount of sun energy that we get. Okay, and again, the sun is what heats us up. Okay, what else influences our weather? And that has to do with the Earth's rotation. So if we think about day and night, in the Earth, not only are we revolving around the sun, but we're also rotating. We rotate towards the sun during the daytime, and then as the Earth is rotating the other way, when it's dark out, we're not facing the sun, and so it's dark, so that's our nighttime. Okay, so that rotation of the Earth causes winds. Okay, so the Earth's rotation causes wind currents to circulate through the atmosphere in certain ways. While moving west to east, so as we think about the way that the Earth rotates west to east, or from high pressure to low pressure, air streams also curve in that direction. So we think that in the northern hemisphere, they're going to curve clockwise. I'll show you a picture of this, okay? So because of the way that we're rotating, it's causing the winds to come up and over. And if we think about in the southern hemisphere, it's opposite. They're going to rotate the other direction, counterclockwise, okay? Let me show you a picture of that. Okay, we call this the Coriolis effect. So the Earth's rotation causes wind currents to circulate through the atmosphere in specific ways. This movement is called the Coriolis effect. And the Coriolis effect causes the wind in the northern hemisphere to curve clockwise to the right as the result of because of the way that the Earth is rotating. And it goes counterclockwise in the southern hemisphere. So these two, they're the same. It just kind of gives you a bigger picture. So here's our equator. Here's our equator. We start here, we go up. Think of clockwise motion in the northern hemisphere. Clockwise, like a clock. In the southern hemisphere, we've got the opposite direction, counterclockwise. Does that make sense?
Yeah.
So what that then does is we get what we call convection in the air. Now, we've talked about convection, and you've probably heard about convection in other areas in science, like when we talk about water, we talk about plate tectonics, you know, the movement of materials. Convection occurs in the air as well. We probably notice this, you know, if you live in a house that has many stories, you know, a two-story house, which floor is hot? Or which floor is warmer? We'll say warmer. I don't know if your house is hot or not.
Top.
Right, it's going to be the upper one because heat rises, okay? Heat rises, it becomes less dense, okay? So that's the same thing that's happening with the air in our atmosphere, okay? So one, we've got this movement of these wind currents because of the rotation of the Earth. I got to move this out of the way so I can see a little bit better. You can see it here in this image. So a band of clouds forms near the equator as moist, warm air rises up. Okay, so here we are at the Earth, the equator. So that moist, warm air is rising upwards, okay, because it's less dense, okay. Warmer heat's going to rise up, okay. As it moves upward, it mixes and it meets cooler air, which is then going to make it denser. And so it sinks back down. And then again, it rises back up, it sinks back down. So it's like this continuous cycle of warmer air rising, mixing with the cooler air, sinking back down, warming back up, sinking back down. Okay, so dry, cooler air sinks as it moves away from the equator, outward towards the north and south poles. This interaction between dry air, moist air, makes it clear why we have so much swirling of these currents, okay? I just got off a plane last night, and you might have heard, like, sometimes if you take a flight, they'll be talking about, you know, the trade winds or the westerlies or, you know, a jet stream. And that's what they're talking about, these wind currents that can, you know, make your flight make it a little longer or make it a little bit shorter, is because the airplane is either getting a ride, not really getting a ride, but catching that air movement, or it's working against that air. Okay. So again, when we think about weather patterns, it has to do with how much, because that Earth is sitting on that axis, how much of the sun's rays are we getting? And then also as we think about the Earth rotating, it's causing the wind to move in a particular direction or pattern. And then we get into temperature when we talk about convection in the air. Okay, if you have any questions, let me know. Okay, so then another thing we get into when we talk about weather is these high and low pressures. You know, you always think about it when you hear a forecast, they're talking about high pressure and low pressure. High pressure is caused by a downward moving air. So as air is forced downward, the pressure increases because it's getting closer and closer to the surface, and it's getting pushed upon and pushed upon. Pressure decreases as you go up into the atmosphere. So why does that matter? As air moves downwards, it will warm and it dries out. Okay, so it's getting closer to the surface, it warms up, and it dries out. With low pressure, it's opposite. The low pressure is caused by upward moving air, and as the air is forced upward, it cools, forming condensation and rain. Let's see, I'm gonna get here soon. So that when we think about the air moving upwards, it can't, and that low pressure, as it's moving upwards, it can't, it's being like pushed. I'm gonna read it here. Since the converging air cannot move downward because the surface is blocking it, it has to move upward. And that leads to condensation and therefore usually a rainy day. So again, as that air can't move down and spread, it's being pushed upward. And as it's being pushed upward, it's pushing and pushing and condensing and kind of getting pressurized. Okay, so you think about that, all that moisture is then condensing, and that's why you'll get, you know, cloudy days and rain. Okay, so some key points here. When we think of a low pressure, so here we are in our low pressure, air cools as it rises up, causing water vapor to condense. And again, that water vapor, that's water in the form of a gas, it condenses and it forms little water molecules, which would then be precipitation. The air is blocked from moving downward, so it condenses. Usually with the low pressure, you'll get cloudy, rainy days, precipitation. Opposite, with a high pressure, you get sinking air, so it warms and it dries out as it spreads. So you get warmer, clear days. There's my preference. Okay. So in activity 5.3.1, it talks about air currents, high and low pressure. So I just wanted to go over these questions. It says pressure, it says blank, this is a multiple choice question. Blank pressure generally brings fair skies and no precipitation. So what kind of pressure would we get if it was a nice day? What would we assume it would be like?
Low air pressure.
You can share, you can take yourself off mute, or you can type your response in. What do you guys think? Do you get variable pressure, low pressure, cold, high pressure?
Would it be low?
So when we get fair skies, no precipitation, we get a nice day, we would get, that would be a high pressure. So high pressure is gonna bring fair skies and no precipitation. Low pressure means falling pressure. Is that true or false? That is true. That's right. Okay. Due to blank, we get high or low pressure systems. So what causes high or low pressure systems? Is it the atmosphere, air currents, rain, or water currents? And that's right. It's B, air currents. Good. We just got two more here. The Earth's rotation causes wind currents to circulate in certain ways. This is called Coriolis effect, climate effect, the jet effect, rain shadow effect. And that's right, thank you. It is a Coriolis effect. Okay, so again, in the northern hemisphere, we get that clockwise motion. Southern hemisphere, we get the counterclockwise motion. Air currents move in the same direction in both hemispheres. Oops, did I just answer this one? You were paying attention. True or false? Air currents move in the same direction in both hemispheres. You're right, that is false. Clockwise in the northern hemisphere, counterclockwise in the southern hemisphere. Okay, so that was a little more information on weather patterns and the Coriolis effect. Does anybody have any questions about that, or any questions that you had on a particular other topic, concept, class, assignment? I'm going to give you a moment here to think about that. You'll have another opportunity. I'll ask again. Okay. Okay, so we'll come back at the end. I'm going to go over a little skill on how to upload and download, and then I'll open up for more questions again. So think about that as we move along here. Don't be shy. Again, I'm here to help you. Okay, so let's move on then. How to download and upload a document. So we don't have a whole lot of, oh, good to hear. Thank you. Someone said they're doing good, understanding. Just, I love to hear that. We'll know that if you ever do have questions, you know, chat away, email away. We're here to help you guys. A lot of activities don't involve, which is great, having to download, upload, save a file, attach it. So that's what we're talking about when how to download and upload a document. But I think in Earth Science, in semester 2, there's one assignment where you have to do so. And then in a couple other science courses, you have the option to attach, like there's a presentation. And so it's kind of the same thing. How do you upload and download documents, presentations, attachments, that kind of thing, okay? And, you know, sometimes you might be like, well, I know how to do that, you know, just doing it on your computer, but maybe working in the program, in the GA program with Buzz, it might look a little bit different. So I wanted to highlight this for you guys. So, okay, so we're gonna take a look at the Coriolis effect. So that's 5.2.1. And what I'm gonna do is I'm gonna go through and show you here, and then I'll actually run through what it looks like. We'll do one together just to make sure. Okay, so when you get to the assignment, this is what it should look like. You know, it talks about the Coriolis effect here. For this assignment, you will select the Coriolis effect on the map of Earth and describe the impacts of this movement. Use the document attached to complete your assignment. Follow the directions below. Okay, so here it gives you the directions on what, whoops, to do. Sorry about that. Okay, so people will be like, well, where is this document at? So when you see this type of a button here, of course there's this little drop down box here that's going to give you, it's like a little information piece. So it gives you a little bit more information on maybe your target or whatnot. This one here this is the attachment. So you see that little paper clip? That's going to be your, that's where the document is located at, okay? So what you'll have to do is you're gonna have to click on that, and then it's gonna open up to how do you want to save it. And you're gonna wanna go to your file, and then you're gonna wanna save as. You wanna make sure that you name it something so that you know it, you can find it on your computer. Okay, so for this particular one, sometimes it'll automatically pop up, and this one does on when I open it up through my word processing program, it names it what it was actually named from the download there, okay? So I save that, and then you wanna think about where are you saving it to? So when I'm working, I usually save everything to my desktop, so it's really handy and I can find it quickly. Okay, and so this is telling you the name of the document, your desktop, and then you would click save, okay? So that gives you then the document. Okay, so then from here, you could go to your document, you'd open up that document, you would then answer the questions. And then of course you would have to save it. Again, now that you've edited it, you always want to make sure that you save your work so that you're not editing or you're not sending in that blank document. So you want to, you'd work on it, select the line that represents the equator on the map. Is it A, B, or C? We would say B is the equator, so you would type right in there B, and then you would come down to, there's 2 more questions here about the arrows, and I'll show you that here in a moment. Okay, after you would save it. And then how you go about to upload it. Well, the same thing is there's this Dropbox, just like we saw here in this activity, show Dropbox. That's where you're gonna drop that document. Okay, so again here, this one gives you another example of what it looks like. Okay, so you would click on that and then you would choose, depending on how you, if you created yours through a Google document or if you created it just like I did, where I just saved that Word document, you would click choose file and then you would just click on the one that you created. Okay, same thing if you did a Google document, you would click that. Then of course you would save and you would click submit. And that attaches that and then it submits your activity. Okay, let me answer this quick chat really quickly here. Okay, so I'm gonna share my screen. Okay, do you guys see this Earth Science semester 2? Is that what you guys see that I'm sharing this? Awesome, perfect, thank you. Okay, sometimes I always had to double check because I don't always get the chance to see what it is it's showing you guys. I always hope it's the right screen. Okay, so this should be what you see when you open up your courses, okay? So here we go to, here we are, 511 weather patterns, and then here's our activity on the Coriolis effect, okay? So if you're here, you're gonna open it up. Uh-oh, sorry guys. There we go. Okay, so here we have the assignments, okay? And then of course down here is the Dropbox. Sorry, I have to scroll so much through this. And here's your attachment. So I would open up that attachment. It's automatically gonna come right here. I'm gonna open it. Okay, so here we have the document. And then we go through and we edit it on here. So, do you guys see the Word document? I want to make sure, did that pop up? Nope, okay. That should do it. Okay, so we determined that B is the equator. So I just type right on there. And then we talk about the directions here. Which direction do winds move in the northern hemisphere? Type in the arrow number below. So remember we talked about northern hemisphere, they move clockwise. So which arrow represents clockwise? Arrow 1, 2, 3, or 4. You got it, thank you. So we would just say arrow. You can just type in 1, you can say arrow 1. Awesome, so we're going clockwise. Which direction do the winds move in the southern hemisphere? Type in the arrow number below. So remember, instead of clockwise, we go counterclockwise. You guys got it. Okay, so as we think about here, we're gonna go direction, as we think in the Southern Hemisphere, we're moving downward. So we wanna move in this type of a direction, okay? Up and around. Okay, so you would type that in, and then it tells you when you have completed your assignment, submit it using the Dropbox. So then you would make sure that you save it. I'm going to change that to my desktop so I can find it easily. And if you guys can't see that, I'm sorry. Okay, well, let me go back to the other screen here. Okay, so then you would show your Dropbox, choose file. Sorry, that's my brain, honey. And then here's my document. And there you go. And then you can type in if you have any comments, and then you would click submit. Okay, so hopefully that helps. Again, you're looking for this little attachment, and then of course the Dropbox is where you're going to attach and then submit. Okay, does anybody have any questions about that? Good to hear. Sometimes I get a lot of questions. Some students just, they're like, how do I do it? I know how to save, I know how to, attach a document, like to email and stuff. And so I just want to make sure that as you see in this program, where those buttons are, where that attachment in that Dropbox is. Good. Okay, so that was a little skill. Again, we talked about weather patterns here. Does anybody have any questions about what we discussed today? Or again, here's another opportunity if you have questions about another topic or another assignment and you want to get an answer, you want to get some help, you want an explanation, I'm here right now for you. Okay, as we think about next week, if you have, again, like I said, if you have a particular assignment or lesson or topic that you know that you might be working on, oh, awesome, I love to hear, so good, so far so good, yay. If there is something that you're want a little bit more explanation on, or if you're already kind of thinking ahead, looking into what you have next week, if you have a topic that you would like me to do a little mini lesson on or go over a skill or an activity, please let me know. I would love to take your input and put that in action and help you guys out. So again, you can tell me here, you can send me a chat later on, you can send me an email. Same thing if I'm not your particular science teacher, the same thing. If there's something that you would like to see, you could just, same thing, you can talk to your teacher. If you can't send me a chat after the session's over, because I'm not your teacher, send your teacher one, and they can either relay the message to me or they'll do one for you on that topic. Okay. Again, we are here to help and support you guys. I hope these live sessions are helpful for you. Again, this will be recorded and saved so that you can view it at another time. Maybe you're not on this particular lesson yet, and maybe when you get to it, you'll be like, oh, that's right, I can come back to it, okay? So yes, if you do have any other questions, it doesn't have to be or science, it can be biology or another science class that you might have. Now is the time, or if you're thinking about next week, if you have a different class, again, I don't have to do just our science or just biology. If there's a topic in another class, please let me know. But yes, if you would like some help here on biology, I would be more than happy to help you. Okay, so you are welcome to stay on. I think I'm going to stick on here and I'm going to talk about some biology. If you want to stick around for that, you are more than welcome to. If you want to log off, my little session on weather is over, but I'm going to help a student out here on biology. I'm just waiting for the chat to come through. So if you want to stick around, great. Or if you're thinking in your mind questions that you might have, that's awesome too. Just don't think, what is she doing? I'm reading chats. I'm helping a student out here with a question. Changes in ecosystems. Okay, let me pull that up. So a student has a question about changes in ecosystems. Okay, so we are looking at bio, I think that's semester review of human impacts. Okay, is there anything specific? Oops. Let's see, go over changes in ecosystems and review of human impacts. Semester 1, did I? Was it in unit 6 or 8? Interaction of cycles. There it is. Okay, so I talked a little bit about some of this last week. Let's see, 2 weeks ago I did a lesson on photosynthesis, and then I did a lesson on cell respiration. Okay, and now this is asking you to put kind of all 3 of those cycles together. Can you see my screen here where it says activity 821? I want to make sure I'm there on the right one. Okay. Yes, good. Okay, so we know that the carbon cycle, photosynthesis, and cellular respiration, they're connected within an ecosystem. So here on Earth, in a particular area, maybe in a forest, all 3 of them are working together for a specific part. They all rely on each other. So when we think about, well, how? Let's look at what each of these do. Carbon cycle, what is produced in the carbon cycle? In the carbon cycle, carbon is produced. Well, the carbon cycle is the transformation of carbon on Earth, okay? So the product here, though, is carbon. So we think about, how do we get carbon? We get carbon from us when we exhale, when organisms breathe out, when they respire. They're giving us as a waste product carbon dioxide, which has carbon. We get carbon from the burning of fossil fuels like gasoline. We get carbon dioxide as well. We also get carbon from, well, carbon comes from, it's naturally occurring here on Earth, but like the fossil fuels, over time dead organisms decompose and it turns into carbon. So the carbon cycle is looking at that transformation of carbon, okay? How carbon gets produced, how it gets used, okay? So you're thinking, well, carbon, to us, carbon's like, it's like a waste product to us, but now let's look at photosynthesis. Photosynthesis is how plants or producers, organisms that produce their own food from the sun's energy, how they make this energy source. And one thing that they need for photosynthesis to take place, we know that they need carbon. So for photosynthesis to take place, you need sunlight, water, carbon, right? And then in the chloroplast of those organisms, those autotrophs, that's where that transformation takes place, okay? So in photosynthesis, we need that carbon, or we don't, but organisms that photosynthesize, produce their own food, they need carbon for that to occur, okay? So cellular respiration, photosynthesis gives us oxygen, energy, and of course, water. So for cellular respiration, that's the transformation of that energy that we get from producers. And that's cellular respiration is the process that changes that sugar that plants produce, producers produce, into a usable form for us. So how these are all produced, it says you can play the role of a carbon atom in an ecosystem. So you could talk about how you were made, okay? Explain how you transform through the different process. Make sure to include your role in the carbon cycle, photosynthesis, and respiration. No set length, as long as you explain the role of carbon in each process. Okay, so here they want you to play the role of a carbon. I've had students come to me and ask, you know what, creative writing is just not my thing. Is there a way that I can just explain the role of carbon in each process? And I say, sure, as long as you explain the role in each process, that works for me. Okay, so try not, sometimes I've had students get really like, I don't want to do it that way. We can make modifications, just, you know, I would always say ask your teacher beforehand. Okay, so we talk about what is the role of carbon in the carbon cycle. Well, we can talk about how carbon is made. You could start off as an organism, say you were, you know, a cow, and then you died and your body decomposed. As your body decomposed, what's left behind is carbon, and that carbon gets, you know, set down into the ground. Another example, we talk about fossil fuels, think about oil and coal, think about organisms that live in sea life. You know, they die, they decompose at the bottom. Their bodies, as they decompose, release carbon, and that carbon gets smooshed into the sediments, and it gets pushed and pushed and pushed and pushed and pushed and pressurized, and over time it becomes, we can use it to burn it as a fuel, and that releases that carbon back out. Okay, as we burn those fossil fuels, plants then, for photosynthesis, use that carbon with the help of sunlight and water to produce their own food. Cellular respiration, the byproduct or the waste product of cellular respiration is carbon. So as we think about, we use that sugar from photosynthesis, that food, that energy, we use it up, and as our bodies transform our cells, because it does take place at a cellular level, as those cells use that sugar, as it transforms that sugar from glucose, which we get from the producer, to what we call ADP, which is the energy that our cells can use, the waste product or the byproduct is carbon. So that's what that is asking you to do, is explain carbon in each three of those. Does that make sense? Good. Okay, human impacts on ecosystems. Was there a particular topic or lesson? Which one? Was it the last one? I'm waiting. Martia, can you explain which one it was? Or can you type in the chat? You just said review of human impacts. So is that looking just at this one? Okay. Okay, so this is a discussion post. So when you open this one up, you're going to find it's going to give you a little prompt with a question. And then, of course, it's going to show you these are all student responses here, okay? Okay, so what they want you to do is after learning about some impacts of, examples of impacts to ecosystems, what role do you feel humans play, if any, in this? What should be done about this to help limit the impact? So when we talk about human impacts, it talked about deforestation. It talked about introduced invasive species, how those can come in and clear out native species. It talked about biodiversity and the extinction and endangerment of species because either humans are, taking up their land, or we're adding pollution, creating pollution. So these are all human impacts that we can have on ecosystems. So they're asking you, and again, it's a personal question, so there's not going to be a right or a wrong answer, but it's, what do you believe? So after going through this unit and seeing this information and seeing examples, what role do you feel humans play in this, if any, and then what should be done about it? So we can hear, in here we can look at some of the student wrote, after learning about the humans' impacts to ecosystems, I feel like we play a very negative role. So there she answered the first part. Nothing we do seems to positively impact the ecosystems. I think we should, and then here's the second part. I think we should limit any further interference, especially with the different species. We should replant everything that we cut down and manage the resources that we take. We need to replenish what we use and restore the balance. Nice response. Okay, so going back to that prompt, and this student, again, explained what role they feel humans play, negative, and then what should be done. And then they listed off a few different examples of things that should be done. Okay, so what you can do is in these responses is you can reply right back here to a student if you want to add on to that and say, hey, I totally agree with you. Those were great resources. I really think that we should, like you said, everything we cut down, we should make sure that we replant. Good point. So you can respond right there. And then of course you can add your own response right here. So if you clicked on new thread, it would then pull up where you would have the opportunity to add your response. Okay, so again, it's a reflection piece. It's about looking at this unit, seeing the information provided to you about human impacts on ecosystems, and then taking that and feeling, sharing what you personally believe. I hope that answered that one. Good. Yay, good, glad I could help you out. Okay guys, we are just about out of time here. So again, if you have more questions like this, these are good examples. If you're stuck on something, you just need somebody to explain it just differently. We all learn differently, and sometimes when we just read through the directions, you're like, well, I'm not sure what they want. I do that all the time. And send a chat to your teacher or an email and just be like, hey, can you rephrase, activity 931 for me? I just don't feel like I quite understand what the directions want me to do. We'd be happy to help you just rephrase that to make sure that you understand what these activities are asking you to do. They're not meant to trick you up or anything like that. And if they are, then of course we'd love to be able to help you. Yay, good. Sounds like I appreciate that. You are welcome for your help. Okay. Okay, so thinking about next week, again, if there's something, a topic or a unit that you would like to see or a particular skill, let me know. I'd love to have a little plan for next week already in my head if I can help you out. Okay, thanks for joining today. Again, this will be saved. You'll get a little message showing where you can find it, but it will be on our library. But okay, guys, have a great day. Good luck in science. Again, we're here for you, and enjoy your courses. Have a good one. See you later. Bye. Yay. See you next week. Come with questions or topics.